Fasten your seatbelts, space fans. Let's blast off into a future where intergalactic travel is the norm. Just imagine hopping from planet to planet like it's catching a local bus. Sounds awesome, right? But here's the harsh reality check. Even with super speedy spaceships, we'd need an eternity of vacations to reach our galactic neighbors. I'm talking over 50,000 years just to get to Alpha Centauri, our closest star buddy at 4.37 light-years away. And if you're feeling adventurous and want to explore the cosmos beyond the Milky Way, like the distant star Icarus, buckle up for a 9 billion-year road trip. No pit stops allowed. Whoa, time to accelerate your knowledge. Even if we reach mind-blowing speeds, like zipping along at the pace of light itself, it's still game over for intergalactic travel in our lifetime. Sorry, space enthusiasts. That's why NASA's top brains are cooking up radical new engines that could potentially shatter the speed of light barrier. But here's the catch: scientists hit a brick wall every time they try to push beyond the limits of physics. Buckle up and join us as we dive into the lab with our resident engineer, where we'll put cutting-edge engine designs to the test. But be warned, we might just need to get creative and bend some serious rules of reality. Buckle up, folks. We're about to explore just how close we can get to lighting speed travel. Now, you might be wondering what's the big deal if our spacecraft zooms in at 99.999% of the speed of light. That's a mind-boggling number courtesy of Norwegian professor Espen Gardar-Haug's groundbreaking math theory from 2017. But here's where things get fascinating. His idea relies on harnessing photons, those tiny, massless particles that always travel at the speed of light. Since photons have zero electric charge and exist solely as they zoom through space, can we really tap into their incredible power to push a spacecraft almost to the edge, but not quite over the speed of light barrier? Alright, let's get our hands dirty and design this revolutionary solar sail. If Espen Gardar-Haug is right to harness photons for propulsion, we'd need a whole new engine type, one that can turn light into motion. And guess what? He thinks the perfect tool for this job is a solar sail. Imagine a massive sail stretching out over 100,000 square meters just to accelerate 1 single kilogram of matter close enough to reach the speed of light. That's right, we're talking about an enormous sail that would utilize sunlight to generate thrust and potentially propel spacecraft at mind-boggling speeds. Buckle up, because this space-age technology is getting closer than you might think. Alright, let's bigexplanr some numbers. An acceleration of just 1 meter per second might sound slow, but bear with me. For our engineer buddy weighing around 70 kilograms, they'd need to create a ginormous square sail with each side stretching over 2.5 kilometers long. That's like lining up 25 football fields end to end. And remember, this massive sail is just for 1 kilogram of matter. We haven't even factored in the weight of the spacecraft itself. But here comes the amazing part: no more fuel tanks. Since we're harnessing the sun's energy, which is essentially limitless and free, our solar sail will have its own self-sustaining power source. Get this, our sun has been shining bright for about 5 billion years and still has a long way to go. It's got another 5 billion years on the clock. Now, our solar sail might start off slow, but here's the cool part: once we get moving, we keep accelerating thanks to that constant, free energy from our star. In just 100 days, our spacecraft can reach speeds of over 14,000 kilometers per hour. That's almost as fast as a jet, and in 3 short years, it'll be zooming along at an incredible 240,000 kilometers per hour. So, buckle up, because with the power of the sun on our side, we could make it to Pluto, one of our solar system's farthest reaches, in just 5 years. Talk about a cosmic road trip. The idea of harnessing constant acceleration using sunlight has really taken off. No pun intended. In recent years, scientists around the world have been pushing the boundaries with cutting-edge prototypes of solar-powered propulsion systems. A game-changer in this area was Japan's 2015 experiment, where researchers from the Japan Aerospace Exploration Agency launched a tiny satellite called the Light Sail 1 into space. This little spacecraft came equipped with an impressive 32 square meter solar sail. That's roughly the size of a small car. And here's what's really amazing: within just a month, this 315 kilogram spacecraft had picked up speed by about 10 meters per second. But that wasn't all. The team was also able to nudge its trajectory in a new direction. The implications for future space exploration. Absolutely huge. That historic 2015 experiment marked the very first successful test of a solar sail in space. And while it was a major breakthrough, it also showed us what we still need to work on. One key challenge is making these sails more agile and responsive to our control. That's why NASA is now busy developing something called the diffractive solar sail. It's a revolutionary new design that uses tiny optical patterns embedded in super-thin materials to grab onto sunlight more effectively. Imagine being able to harness the power of every photon, and you'll get an idea of just how powerful this technology could be. And here's the mind-blowing part. With the help of these advanced solar sails, we might one day make it possible to travel not just around our own solar system, but all the way to the nearest stars. The possibilities are truly limitless. But here's where things get really tricky. When it comes to reaching other star systems, our trusty sunlight just isn't enough. The farther away we are from the sun, the fewer photons there are to catch onto our sail. That's why a team of international scientists is joining forces on an incredible project called Breakthrough Starshot. Their plan: to build thousands of tiny solar sails, each one lighter than a paperclip at just 1 gram. These mini marvels would need way less light to get moving, making them the perfect solution for a journey across vast interstellar distances. The possibilities are endless with this tech. Imagine it propelling tiny spacecraft to nearly 20% of the speed of light and reaching our nearest star neighbor in just over 20 years. Now that we've got our super lightweight mini sails in place, it's time to talk about how they'll reach those incredible speeds. Back on Earth, researchers are gearing up to build an epic array of powerful laser installations. We're talking a whopping 100 gigawatts of energy. These beams will be precisely aimed at the tiny solar sails, giving them the boost they need to take off into space. The ultimate goal: to reach Proxima Centauri, our sun's nearest neighbor, in what feels like a cosmic blink of an eye, or so it would seem. While accelerating these photon sail spacecraft to 20% of light speed will take a solid 30 years. Mark your calendars for 2030, when we'll finally leave the solar system. Fast forward another 30 years to 2060 and our tiny explorers will be zooming past Proxima Centauri. Get ready for humanity's next giant leap. Now that we're dreaming big, let's see what it'd be like if our engineers managed to push those photon sail spacecraft to a mind-blowing 90% of light speed. Buckle up, because at this velocity, time would get seriously relative. Imagine our engineer taking a quick trip to Mars and back. Sounds easy, right? But here's the twist: due to time dilation, for our speedy astronaut, that round trip would feel like just a few weeks. Meanwhile, on Earth, decades would have passed. It's mind-bending stuff, and it's only the beginning of what awaits them at such incredible speeds. The countdown is on. It'll take just 16 minutes and 40 seconds to blast off to Mars and back with our photon sail spacecraft, right? But here's the wow factor: while Earthlings will still see that same 16-minute journey play out, our speedy astronaut will experience time in a whole different way. Due to mind-bending time dilation, the entire round-trip adventure will zoom by in a mere 8 minutes and 20 seconds for them. This phenomenon occurs when you're traveling at extremely high speeds, and trust us, it's just the beginning of the thrilling consequences. As we hit hypersonic speeds near light, the effects of time dilation get wilder. The space ahead, it's about to go from a clear path to a crazy tunnel vision experience. Everything in front of us appears flattened and blurry. Before long, all that awaits is an endless stretch of darkness. Here's why: when you're zooming along at such incredible velocities, light waves just can't keep up. It's like the universe literally slows down its signal, leaving our engineer facing a truly eerie void. Think you can build a photon engine and hit light speed? Well, the tech's actually out there in theory. The catch: we need an insane amount of materials to build the sail and mind-boggling energy to power those laser beams. For now, we're stuck on Earth, but scientists are already cooking up plans for a new, game-changing engine that defies our current photon limits. Buckle up, these geniuses are working on a revolutionary concept that's going to change everything. Ready for liftoff. Theoretical physicists are proposing a mind-blowing solution: harnessing antimatter to power our space travel. Imagine combining this mysterious stuff with regular matter. The reaction would unleash an enormous amount of energy, crushing even nuclear fusion's might seva, which is already pretty powerful. Antimatter reactions are 1,000 times stronger than nuclear decay and a staggering 10 billion times more potent than any ordinary chemical reaction. The question is, can we tame this incredible power to make interstellar travel a reality? Blast off is looking far-fetched if we can't get our hands on this rare stuff, right? Here's the challenge: making and storing antimatter is like solving a cosmic puzzle. It's super tricky and guzzles an outrageous amount of energy. To make space travel a real possibility, brilliant engineers are brainstorming a hybrid engine that could use far less antimatter. It's all about finding ways to stretch this precious resource and unlock the secrets of space exploration. Fasten your seatbelts for a blast from the past. Back in 1992, geniuses at the University of Pennsylvania cooked up an idea called the antimatter catalyzed microfusion drive. This sci-fi engine had it all: a special capsule packed with super heavy fuel, deuterium, tritium, and uranium-238, which was then blasted into a reactor chamber. There, it got smacked by a barrage of ions followed by an anti-proton beam. The result? Matter started to vanish in a puff of energy, kickstarting the decay of uranium-238. This chain reaction ignited a fusion fire with deuterium and tritium, unleashing untold power. Here's the thrilling part. This mind-blowing energy kicks off an electrical storm that supercharges gigantic magnets. These magnetic monsters heat up the plasma until it's almost as hot as the sun. With precision control, magnetic fields guide the scorching plasma through a nozzle like a rocket's exhaust pipe. Whoosh, that's when thrust happens and your spacecraft starts to soar into space. Now here's where things get even more amazing. This antimatter drive is a real game changer because it only needs an incredibly small amount of that rare stuff for long-distance travel. Yep, you heard right. Just 100 grams would be enough to send a spacecraft all the way to Pluto. Scientists are indeed creating this precious stuff called antimatter in gigantic machines called particle accelerators, which can crank out tens of millions of teeny tiny antiprotons every minute. Sounds impressive, right? But here's where things get really wild. If we keep that rate up, it'd take an astonishing tens of billions of years to produce just 1 single gram of this elusive stuff. Mind blown, right? That's why antimatter has earned the title of being the most expensive substance on our planet, and we're talking astronomical prices. Imagine having just 1 gram of antimatter. The price tag, a whopping hundreds or even thousands of trillions of dollars. It's not just about creating these tiny particles, though. Storing them is a whole different challenge. See, when matter meets its antimatter counterpart, bam, they annihilate each other in an instant. So, no simple container will do the trick here. That's why scientists have to get creative. They use special electromagnetic traps called penning traps to keep their precious antimatter from meeting its untimely demise. Let's dive into the world of portable antimatter storage. Game changers in the making. Scientists are whipping up compact traps using powerful magnetic fields and near vacuum conditions, all at extremely low temps. The goal? To keep those pesky antiparticles from self-destructing before we can even study them properly. And get this, engineers are now working on super portable versions, which could soon allow scientists to ship their precious cargo between labs. One such brainchild is being developed by the European Organization for Nuclear Research, though it's still a beast of a device, measuring 2 meters long and tipping the scales at a whopping ton. Now, let's imagine our top engineer has somehow managed to snag enough antimatter. How safe would they be zooming through space on a starship with this baby as its engine? But hold up, space travelers. Let's assume our genius engineer somehow cracks the code for faster than light travel, no harm done to them or their crew as they blast off into the cosmos. But here's where things get seriously dicey. What happens when it's time to put on the brakes? Picture this, a lone photon drifting through space, just chillin' until our antimatter-powered spacecraft zooms in and gives it a cosmic traffic jam. That photon gets stuck at the ship's leading edge, and when the rocket finally touches down, those trapped particles all release their stored energy at once, a catastrophic explosion of epic proportions. We're talking enough radiation to not only wipe out our starship and its crew, but potentially entire planets. Now, you might think that if our engineer slows down gradually before landing, they'll dodge the cosmic catastrophe. But sadly, it's not that simple. Even with a gentle deceleration, the ship would still release an enormous amount of photon radiation, enough to fry everything in its vicinity. This is exactly what Italian physicist Stefano Finazzi and his team warned us about back in 2009. They calculated that the heat from these stuck photons would be off the charts, a scorching 10 to the power of 32 Kelvin, or an eye-watering 142 million degrees Celsius. Temperatures last seen during the Big Bang. So, it turns out even a quick jaunt at light speed could spell disaster for entire planets. But here's where things get really mind-blowing. Scientists also warn that if we were to actually travel faster than light using an antimatter engine, it could have a catastrophic impact on our entire universe. So, how can this be? It all comes down to the laws of physics and something called spacetime. In 1994, physicist Miguel Alcubierre proposed a revolutionary idea, a warp drive that would bend space itself around the ship, making it move without actually moving through space. Instead, space-time would contract in front of the vessel and expand behind it, kind of like creating a bubble or a warp. This mind-bending concept could potentially allow us to travel faster than light, but it raises more questions than answers about the universe's delicate balance. The cool part, this warp drive idea lets our spaceship cheat the light speed limit without breaking the rules. It's space-time that does the moving, not the ship itself. Think of it like being on a magic carpet ride, while the ground beneath you zooms past. But hold up, because there's a huge catch. According to Alcubierre's calculations, creating this warp bubble would demand an insane amount of energy, nearly every single bit of power that exists in our entire universe. Alright, so our Alcubierre drive spaceship zooms through the cosmos without breaking any laws of physics. But here's what keeps scientists up at night: maintaining stability during warp speed and exiting it safely might be impossible. But for the sake of imagination, let's say we conquer those hurdles. Now, picture this: our ship whizzes past stars at mind-boggling speeds, leaving us to ponder another daunting challenge. You see, Alcubierre himself warned that his drive could turn ordinary space travel into a time machine. And that's where things get really weird. Mind blown yet? Here's where things get trippy. Any FTL travel method comes with time travel as its ultimate side effect. Alcubierre's warp drive creates closed time-like curves, which basically means it can send our spaceship back in time to a different moment, all while still returning to the same location. Imagine space-time folding in on itself like a tunnel, and if we speed through it, we could end up thousands of years into the past. That's the wild reality of faster-than-light travel. Buckle up, because things are about to get seriously wild. If faster-than-light travel becomes a reality, we could be looking at some serious cosmic chaos. The butterfly effect comes into play here. Remember the classic movie, The Sound of Thunder, where stepping on a butterfly in the past has massive consequences for our present? Yeah, it's not just sci-fi. Altering even the tiniest detail can send us spiraling down a drastically different timeline. But before we get too excited about exploring the cosmos, there's one major catch. To make this work without wiping out existence, we'd need to rewrite the fundamental rules of physics. The question is, can we actually do that? Get ready for a game changer. In 1999, British engineer Roger Shearer dared to dream big. He claimed he'd cracked the code to outsmarting physics with his mind-blowing invention, the EM drive. This rocket model is like nothing we've ever seen before. It's basically a hollow tube with super powerful electromagnets inside. But here's where things get really cool and confusing. Scientists say that electromagnetic waves start bouncing around this cavity, kind of like a cosmic game of ping pong, and they travel from the magnets throughout the device. When these waves hit the narrowest part of the structure, magic happens. They accumulate, creating thrust in the engine. The question is, can this defy the laws of physics for real? Fast forward to 2016. NASA's Eagle Works Laboratories was ready to put Shearer's EM drive idea to the ultimate test. Their team conducted an experiment, and what did they find? They claimed to have measured some seriously promising results. This thing might actually work. It looked like we were on the cusp of a revolution in physics. But just as things were getting exciting, a team from Dresden Technical University, led by Professor Martin Tajmar, threw some serious shade. They decided to try and replicate NASA's experiment, but with one big difference: their results. Zip, zero thrust. The EM drive was back to square one, leaving us wondering, what exactly is going on here? But here's the twist: that measurable thrust NASA's team detected wasn't actually a result of the EM drive defying gravity, but rather a thermal effect playing a sneaky trick on their sensors. In other words, the sensor was picking up the engine's heat, not some futuristic propulsion power. So if we were to slap this technology into a spaceship and hit the gas, it'd just be stuck in park. The EM drive wouldn't give our spacecraft the speed or maneuverability needed to explore space. The laws of physics remain unbroken, and scientists still haven't found a way to harness the power of the EM drive for real space travel. The EM drive team isn't giving up anytime soon, though. They're pushing the boundaries of space travel. But here's where things get crazy. Any journey to other galaxies or beyond our solar system would require breaking the ultimate speed limit, light. And according to Einstein, that's just not going to happen. As a spacecraft zooms closer and closer to light speed, its mass starts to skyrocket, basically making it impossible to go faster. It's like hitting an invisible wall. As you approach the speed of light, your spaceship would weigh more and more until it'd be practically stuck in place. Einstein's theory of relativity is pretty clear. In our universe, light is the fastest speed possible. Buckle up, folks. Scientists are thinking outside the box, or in this case, our universe's speed limit. They're proposing mind-bending ideas to outsmart Einstein's rules and travel faster than light without actually going that fast. Imagine space-time as a stretchy grid warped by massive objects like planets and stars. It's like a cosmic trampoline. With enough gravity, scientists think they can create shortcuts or wormholes through this fabric. These tunnels would let spacecraft zip from one point to another, skipping the usual distance altogether. It's like teleporting, but instead of just moving information, we're talking actual spaceships and travelers. Talk about a game changer. All right, let's talk about the cosmic adventure of a lifetime: interstellar travel through wormholes. Some scientists are convinced these tunnels could be our ticket to exploring distant galaxies. Now, there are different theories on where to find these wormholes. While some think they might only exist during the universe's creation, others propose hunting for them near supermassive black holes, mind-blowing locations with incredible gravitational pull. But hold up, buckle your seatbelts, because things just got intense. If we did stumble upon a wormhole and managed to travel through it, the acceleration would be so extreme that particles inside would basically become cosmic radiation bombs. Not exactly safe for human space travelers. And if we were crazy enough to build a warp drive ship right now, the risks could actually unravel the fabric of our universe. Talk about a paradox. Faster than light travel might mean a one-way ticket to destruction. Think about this. If we're pushing our technology to go beyond light, what's stopping us? But here's the thing: unlike cars or even those super cool fighter jets that can break the sound barrier, there's a fundamental limit in space: the speed of light. No matter how hard you press that cosmic gas pedal, you just can't go faster. So, trying to outsmart this natural boundary could backfire in a major way. It's like trying to cheat the laws of physics. Instead of saving us, we might end up putting our existence at risk. So is it even worth playing with fire and trying to beat something that's literally set in stone? Or should we focus on other ways to explore space and the universe around us? But here's a crucial catch. No matter how fast we want to go, our speed is capped at a whopping 300,000 kilometers per second. That's when hitting the cosmic speed limit becomes a reality. The problem: we'd need an energy source that can keep up with that incredible pace and power us through space forever. Since we're not quite there yet, it seems like breaking the light barrier might be more of a fantasy for now. But don't lose hope. Science has shown time and again that what seems impossible today can become tomorrow's discovery. The question on everyone's mind: could we be just a few decades away from rewriting the space travel rulebook, or is interstellar adventure